Okay, so in a previous video, we talked about the different types of bonds and how some bonds are stronger than other bonds. And we talked about also dipole-dipole interactions versus dipole-induced dipole interactions. And we said that dipoles needed an electronegative atom to withdraw that electron density. And so if you're looking at the electron density table shown over here, or this electronegativity table shown over here, we were saying that if you had something on the left-hand side, which is more electronegative, that can withdraw electron density from something that is on the right-hand side, which has more electropositive. So the idea here, and I wanted to kind of make a video on H-bonds because we said that it's a specific type of dipole-dipole interaction, which involves a hydrogen, and I wanted to make a video so you guys can understand when you're seeing an H-bond and common misconceptions students make about H-bonds. So for H-bonds, again, it's a type of dipole-dipole interaction, but specifically this one is a little bit stronger. The reason why it's a little bit stronger is because you can form a little bit larger partial charges. And remember, if we talked about Coulomb's law, the larger the charges are, the larger the attractive force, meaning that it is a stronger bond and it requires more energy to break. So again, it involves permanent dipoles. And the key idea here is that it's an intermolecular interaction. And intermolecular, all that means is it's between two molecules. So a lot of students think that the hydrogen bond is the hydrogen within one specific molecule, and that's not what a hydrogen bond is. So for example, if I drew water for you guys, this by itself, this is not a hydrogen bond, okay? This is a hydrogen bond that's in oxygen, but this is not a hydrogen bond because a hydrogen bond requires two molecules. It's an intermolecular interaction, okay? So the basic format of what you need for a hydrogen bond, there's three things that you need, okay? And we're just gonna give you, so I'm gonna give you like kind of like a symbol, and then you can use this to, you can use this as like a general format so that when you wanna see if you have a hydrogen bond. So the format that you need, and I'm gonna just draw it out over here. Okay, so what I did over here is I drew an H bond donor and an H bond acceptor. Okay, so to have a hydrogen bond, you need three things. Okay, the first thing is itself the hydrogen. So we have that hydrogen shown over here attached to the X. What I'm saying by the X is it's any electronegative atom, and specifically for a hydrogen bond, you need X to equal to a nitrogen, an oxygen, or a fluorine. But there's only, I think, three naturally occurring molecules that have fluorine in it. So for the most part in this class, we're just going to talk about nitrogen and oxygen. Okay, so you need that electronegative atom. So the first thing you need is the hydrogen. Then you need, the second thing you need is you need the hydrogen to be directly connected to an electronegative atom. And what this does is, so if we have the hydrogen connected to the electronegative atom, okay, so the electronegative atom has a partial negative charge because it can withdraw electron density. And because it can withdraw electron density, it makes the hydrogen partially positive, okay? Then what you need is a different molecule that also has an electronegative group, okay? This one has lone pairs. Notice how it's going to have lone pairs. It's going to then donate it's going to have electron density to donate to the hydrogen. So that delta minus from that electronegative atom over here, we call that the H Bonds acceptor. So the thing that the hydrogen is, the electronegative atom that the hydrogen is directly connected to, that's the H bond donor, okay? Then the thing that's donating electron pairs to the partially positive hydrogen is called the electron acceptor, okay? And you need those electron pairs. So the idea here is, again, you need the hydrogen, you need that hydrogen to be directly connected to the electronegative atom, and then you need an H bond acceptor, which also has its lone pair so that it can donate electron density.